Hey everybody, what's going on? Welcome back. I'm so excited that you're here. Welcome to Unit 2 Chemistry class on atoms. I'm so excited to jump into this next stage of our class. You guys have done a fantastic job on the measurements unit, and we're moving more and more into actual chemistry. So many of us have heard of atoms. We might know a little bit already how atoms are even made up of 3 smaller parts. We're going to get into that, don't worry. Today's lesson, I have a learning target for us. At the end of this lesson, I want you to be able to say, I can identify the difference between atoms, elements, and compounds. That's our goal. This whole video right now, it's 6-7 minutes long. At the end, I want you to be able to identify the difference between atoms, elements, and compounds. So let's jump right into it. Have you ever wondered why some metals are more expensive than others? Think about that. Everything is just made of stuff, right? So why is some stuff more valuable than other stuff? On this picture, you see a gold bar, which in today's world is worth about $61,000. Imagine that gold bar like in your hand, and somebody would be willing to give you $61,000 for 1 bar of metal. Okay? Interesting. Why is that? Look at this picture. This is an asteroid. Now, this is a real rock that's flying through outer space. And we have figured out that this asteroid is made of iron. And because of how big this asteroid is and how much iron is worth today, this asteroid, if somebody was able to fly a ship up there, land on it, and get the iron off of this asteroid would be worth $10 quintillion. That is a 10 with all those zeros after that. So that's another metal that's worth a lot of money. So let's keep going. Look at this. We got copper. Copper is great for pennies, right? We've got lithium is another metal. This is the battery that's in your cell phone, and it's in the battery of your iPad if you're watching on your iPad. Lithium is really great for batteries. You've got aluminum is another metal, and it's really lightweight and durable and flexible, and it's great for cans. Every can of pop is made out of aluminum. All right, there's some more. Check these out. This is calcium. And you might be thinking, Murchie, that's a powder. Yep, some metals take the shape of powder, which is kind of cool. In fact, calcium is really important for your bones. So if you're drinking milk, you're actually drinking metal. Isn't that crazy? Look at this. You got magnesium. You got titanium. The new iPhone 15 Pro or something is made out of titanium. So all these metals are good for different things. They behave differently, have different properties. This you already know, but check this out. What makes one metal different than another metal? Okay? What makes metals different from one another? And then you might be asking, well, what makes anything different from anything else? Why is metal different than water? Why is air different than a desk? Like, what actually is the difference between these things? This is a question that has been asked for thousands and thousands of years. And back in the day, folks thought that everything was made of either earth, air, fire, or water. Okay? Earth, air, fire, and water. They would think, okay, look at an apple. An apple has juice, so it's made of some type of water. It also has a texture to it. So apple is a combination of earth and water. Everything is made of either earth, air, fire, or water. Okay, and this belief is what we all thought for a long period of time. But then somebody had the question, what are earth, air, fire, and water made of? And that's a good question, right? Because if you're going to say it's made of earth, well then ask the question, what's that made of? And then ask the question, what's that made of? What is stuff really made of? Long story short, it took about 2,000 years, but we figured out that everything on Earth is made of only 92 different things. These are called elements. They are listed on the periodic table of elements that you can see on your screen right there. Now, we're going to get into the specifics of how this table is designed a little bit later, but I just want you to know that everything you've ever touched, everything you've ever breathed or seen is made up of one of these 92 elements. Okay? Let me give you an example. An element is a substance that can't be broken down into another substance. Now, if you need to pause your video and write this down, that'd be great. There's another chance later on if you miss it this time. But An element is a substance that can't be broken down into another substance. Let me give you an example. You all have had a glass of water before, and you have all heard people refer to water as H2O. Maybe we haven't thought about why is it called H2O? Well, let me explain. Water is a substance that can be broken down into another substance. So water is not an element. Water is made of elements. And for example, water is made of 2 hydrogens, that's what that 2 means, 2 hydrogen elements, and 1 atom of oxygen. So water is not an element, it's a combination of elements. It's called a compound. We'll deal with that in a minute. But I just want you to know that if you have hydrogen by itself, you could call it an element. If you have oxygen all by itself, it's an element. But when they combine together, it's called a totally different thing. So an element is a substance that cannot be broken down into another substance. Now check this out. Let's imagine that elements and atoms and compounds and all that, let's say they're paper clips, right? An element would be like a group of paper clips that are all the same thing. You've got many different ones, but they're all identical, right? If you were to pull one of those paper clips out and move it by itself, you could call that an atom. But when it's all together and bonded and touching and all like that, that's an element. Separated by itself, it's an atom. And if you combine it and bond them with other atoms, that's called a compound. Look at that picture of the colored paper clips. You got blues and whites and pinks and greens. In our mind, that is an example of a whole bunch of different kinds of atoms mixed together, bonded together, and you call that a compound. Okay? So write these definitions down. You can go ahead and pause the screen real quick. Write these down, and we'll pick up in just a second. Lastly, look at these pictures and label them based on whether you think they're more like elements, atoms, or compounds. Okay? If you think it's an element, put an E next to it. If you think it's an atom, put an A, put a compound, and a C. And when you're finished with that, show Mr. Murchie, and he can sign off, or you can start in the next thing. Thanks so much. Have a great day. Bye-bye.